Hello, this is part 3 of section 6.4 and 6.5 notes. Today we're going to do quadratic and form equations. Now, quadratic and form means one of your variable terms is the square of the other variable term. And when you have something like this, you can actually use factoring, quadratic formula, or completing the square to solve the equation after a simple u substitution. So example 3, part A. So we have 25 to the x equals 5 to the x plus 6. Now, if that 6 wasn't there, we'd be able to just get the same base, cancel the bases out, and solve for x. But because of the plus 6, we can't do that. I still am going to get the same base, though. So this is 25 is the same thing as 5 squared. So that's 5 to the 2x equals 5 to the x plus 6. And actually, instead of writing it like that, I'm going to write it like this, 5 to the x squared. So that we see my one variable term is the square of the other variable term. So because this is quadratic in form, like I said, we're going to do what's called a u substitution. So let u equal 5 to the x. So then we get u squared, because of the squared in the equation, equals u plus 6. This is a quadratic equation now, so I'm going to subtract u, subtract 6 from both sides. U squared minus u minus 6 equals 0. And like I said, you can complete the square quadratic formula. I am just going to factor it, though. So we get u equals 3 from the first factor, or u equals -2 from the second factor. Now, the u substitution makes solving the equation very easy, but it adds one last step at the end, because our original equation we were asked to solve for x, not u. So we're not quite done yet, but what we can do now is replace the 5 to the x. So we get 5 to the x equals 3, or 5 to the x equals -2. Now for this one, I'm just going to take log base 5 of both sides. So we get x equals log base 5 of 3. But for the second one, 5 to the x equals -2. If you remember about exponentials, they never cross the x-axis. So an exponential can never be negative. So there's no answer there. And let's say you didn't quite remember that. When you would go through and take the log of both sides, you can't take the log of a negative. So that would leave you with the no solution as well. Now, part B is a little tricky because it doesn't actually look quadratic in form at first. Because e to the x is not the square of e to the -x or vice versa. So what we're going to do, though, whenever you have something like this, we're going to do some manipulation. So that gives me e to the x minus e to the -x equals 10. Now I want to get rid of that negative exponent. Well, to get rid of the negative exponent, I'm going to distribute e to the x. Now I'm actually going to show every single step with this distribution. So this is e to the x times e to the x minus e to the x times e to the -x equals 10e to the x. So for the first distribution term, you add them. So x plus x is 2x. The second distribution term, you also add them, but you get x plus -x, which is 0, equals 10e to the x. So we get e to the x squared, because that's what e to the 2x is, minus 1 equals 10e to the x. I'm hoping now you can see how this is actually quadratic in form. So let u equal e to the x. So then we get u squared minus 1 equals 10u. Subtract 10u from both sides. u squared minus 10u minus 1 equals 0. This one's not actually factorable, so I'm going to complete the square. So add 1 to both sides. So we get u squared minus 10u. Actually, let me scoot it over a little bit. U squared minus 10u equals 1. Then this is where you need to add half of negative 10 squared, which is 25. So we're going to add 25 to both sides. So that means we get u minus 5 squared equals 26. Take the square root of both sides. So then we get the absolute value of u minus 5 equals the square root of 26. To get rid of the absolute value signs, it's u minus 5 equals plus or minus square root of 26. And then add 5. We get u equals 5 plus or minus square root of 26. And again, replace the u back with e to the x equals 5 plus or minus square root of 26. Take the natural log of both sides. That'll cancel out the e. So we get x equals ln of 5 plus or minus the square root of 26. Now, 5 plus the square root of 26 is obviously a positive number since both 5 and the square root of 26 are both positive. But since the square root of 26 is bigger than 5, when we do 5 minus the square root of 26, that'll give us a negative answer. So we can't take the log of a negative. So again, we only have one answer, and it's 5 plus the square root of 26. Then one last one, part C. As you can see, we have a log of t squared and then a log of t. Now don't make the mistake of doing this property. This is not equal to 2 log of t. That's because it would have to be written like this, where the squared's on the t, not on the log. This is equal to 2 log of t. So don't make that mistake. But since we have a log squared and a regular log, let's use u equals log of t. So then we get u squared equals 2u plus 15. Subtract 2u and 15 from both sides. U squared minus 2u minus 15 equals 0. Factor it. What is that? U minus 5, u plus 3. So then we get u equals 5 or u equals negative 3. Again, we have to put the log of t back in now. So that would be log of t equals 5 or log of t equals negative 3. Now the base of this logarithm is a 10, so I'm going to 10 it up on both sides of both equations. So we get t equals, now 10 to the 5th power is 1 with 5 zeros. And then 10 to the negative 3rd power is a 0 with 3 decimal points and a 1. So there's actually only 2 zeros between the decimal point and the 1 because the 1 takes up the 3rd decimal place. And you can plug both of these in and check and see if they work, and they both will work. So those are our solutions. That's it for this part of the notes.